guys, so we're still busy with stoichiometry, but today we're going to be revising, actually, work that you've done in grade 10. And I'm specifically referring to percentage composition, empirical formula, and molecular formula. Okay, so what is percentage composition, first of all? So percentage composition of a substance is the percentage by molecular mass that each element contributes to the overall formula. So that means that if I have a compound and I determine its molecular mass, and I now want to know how much does a specific element contribute to the entire molecule, right? That will be my percentage composition. Now, the next one that we mentioned was empirical formula. Now, what is empirical formula? It is the simplest formula of a compound. So it just tells us the ratio in which certain elements come across in a compound. It doesn't actually tell us how many specific come across in a compound, just only the ratio. And that brings us to my molecular formula. And the molecular formula is the full formula of the compound. So actually, how many of each element there is in one compound. Okay, now, so let's start with percentage composition. Now, percentage composition, in a question, they will give you the percentages. So you'll have your given percentages. Then you use these percentages as if they are the given masses of each. Then, using these in grams, determine the mole of each. Then the mole can be used to determine the empirical formula.
This brings us to the empirical formula. So, once the mole of each element is calculated, just see the percentage composition for that. Identify the smallest value or number of mole. Then you have to divide each of the calculated moles by this smallest value. This will give the ratio of each element in the compound or molecule. Now write out the empirical formula. That brings us to the molecular formula, or aka the actual chemical formula. So once the empirical formula is found, calculate the molecular formula of the compound. Divide the actual or given molecular mass by the molecular mass calculated using the empirical formula. This will give you the multiplication factor. Multiply the ratios in the empirical formula with this multiplication factor. And ta-da! Now you have your molecular formula.
So let's do that as an actual example. Let us look at this example here. They say vinegar, which is used in our homes, is a dilute form of acetic acid. A sample of acetic acid has the following percentage composition: 39.9% carbon, 6.7% hydrogen, and 53.4% oxygen. Number 1. Determine the empirical formula of acetic acid. Number 2. Determine the molecular formula of the acetic acid if the molar mass of acetic acid is 60.06. So let's begin. Now, the first thing we said we wanted to do is we want to calculate the percentage composition. So for carbon, we have a given percentage of 39.9%. Now we use the percentages as if they are the given masses of each element in grams. So we can say for carbon, the mass is equal to 39.9 grams. And then where we go from here is now we calculate the moles, but first we need the molar mass. So the molar mass for carbon is, where is my formula sheet? Here we go, is 12 grams per mole. And we want to find the mole. So now we copy the formula. And that doesn't change. So now we know that it is 39.9 divided by 12. Which gives us 3.325. And it is ideal if you do not round off at all during these stages. Right, so that is for carbon. Now, let us, I'm just going to write it here, move on to the next one, which is hydrogen. And hydrogen has a given percentage of 6.7%. Again, we now use this as if it is my mass. So then it is 6.7 grams. The molar mass of hydrogen is equal to 1. So to determine my mole, it is going to be 6.7 divided by 1, which equals to 6.7 mole. Oops, it's a unit, so now E there. Ooh, there either. Okay, and then I'm going to use this space. Now we're looking at oxygen, which has a given percentage of 53.4%. So we take it that its mass is 53.4 grams. The molar mass is 16 grams per mole. So that's 53.4 divided by 16. So that's going to give us 3.337. And again, do not round off. Ugh, what is it with me and the E? Okay, so now I have the mole of each of these different elements that come across in my compound. Now I can move on to determine the empirical formula. So my empirical formula, let's just say that's what we're doing, empirical formula. Right. So once the mole of each element is calculated, we have to identify the smallest value or smallest number of mole. So if we look at our different values, this value is 3.325, this value is 6.7, and this value is 3.3375. So which one is the smallest of these three values? Well, if I'm not mistaken, it is this one, the one for carbon. So for carbon, it's going to be 3.325 divided by 3.325. And that's going to equal to 1. For hydrogen, I'm going to have 6,7 divided by 3,325, and that is going to equal to 6.7 divided by 3.325, and that gives me a 2. Okay, so it's ratio, so we're going to round it off. And then finally for oxygen, we have 3,3375 divided by 3,325. So that is 3,3375 divided by 3.325, and that gives us 1. Okay, so if I write out my empirical formula, it will be C1, so we don't actually write the 1, H2O1. And that is my empirical formula, which then obviously brings us to our next step, and that is our molecular formula. Okay, so when we need to determine our molecular formula, once the empirical formula has been found, we now calculate the molecular formula of the compound. So what we do is we divide the actual or given molecular mass by the molecular mass calculated using the empirical formula. So my given molecular mass was 60,06 grams per mole. Sorry, given. And then the molecular mass for the empirical formula is equal to, so for C, so it's CH2O, so C is 12, 1 times 2 plus 16, and that is going to give us 30 grams per mole. Right, so now to get our multiplication factor, there we go, we're going to say 60,06 divided by 30, and that is going to give us 2. And now we have CH2O times 2, which will give us C2H4O2, and that is my molecular formula. Okay, that's how you do it. And now I want you guys to do exercise 8-5. Can you do it? Can you not? Can you do it? Can you do it? Can you not? I don't know. I'll put the corrections on the screen.
Big addition, I can go.